Hi, my dragons. Dr. Victor here. I'm a professor at Tiffin University, and I've been here for a long time. It's going on my 32nd year, and I've designed a lot of programs, including forensic psychology, undergrad and grad, several of the graduate programs, and a lot of courses, this being one of them. I was also the first dean of the School of Criminal Justice, so I'm very excited to have you in this class. So research, design, and analysis is one of those classes that I'm well aware that students look at with a great deal of trepidation. But really it's a lot of fun, and I hope that you have an excellent semester here, or term, and that you come to love it as much as I do, okay? So we're going to get started on the intro to research, design, and analysis, which basically covers history, okay? So I want you to sit back, relax, and enjoy this lecture. I will also provide a lecture outline for you so that you can take notes if you want to, but you can always go back and view the video again, okay? So let's look at where research started, okay, from the beginning to now. So we have a long and ever-evolving history of research. It came over a long period of time, and some of the greatest researchers and thinkers of humanity have contributed to this. It is deep within the heart of man to want to know and explain and predict things around them. So that's where research comes in. If you're the kind of person who's curious about things, or you're the one who's the kid that's always said, well, why is the sky blue and why does the wind blow like that? So full of curiosity, as Rudyard Kipling said, insatiable curiosity, then research is for you. Research is just a way to understand and to answer the questions that you have in a very predictable way. And you can do this, okay? So it's a long history, and it winds through a lot of cultures, a lot of history, a lot of different fields, and all of these things have left their mark on history. So starting with the ancient Greeks and the Zoroastrians to the Hubble Space Telescope, the scientific method underlies everything, development of all science in all areas, and you rely on it every single day, whether or not you realize it. When you get up in the morning and you brush your teeth, you are relying on someone who designed your toothbrush and who gave you toothpaste, a type of toothpaste that wouldn't rot your teeth or anything like that. And those are all inventions inspired by research, and we have to try and do the best that we can to make the products that we all use every single day. So from two great cultures, the Greeks and all of the ancient Muslims and Arab cultures, comes research, okay? And they traded knowledge, and they had a mutual respect for knowledge. And so today we're going to start with the ancient Greeks. So research came from philosophy and religion, because those were the great first steps of humans. So today we have a model of research that is mathematical and step by step. We call it a stepwise progression. And we use that to disprove theories or answer questions that we have. So initially, the Greeks were philosophers, and they didn't basically look at measurement or science or mathematics. They looked at those type of things for laborers or craftsmen or artists. So gradually we began to apply those things to research. So some of them, Plato, for instance, he was a philosopher who believed that knowledge was the province of reasoning, and you could solve everything through reasoning, therefore measurements weren't necessary. But the first philosopher to really recognize empirical or mathematical measurements was Aristotle. And Aristotle believed that measurement was important, and it was the foundation of knowledge and the only way to advance that knowledge and continue to where it is today, to be accurate, to be measured. So because of this, Aristotle is generally thought of as the father of science. He furthered this evolution by his dedication to measurement and measurement of things that he observed. Abstract reasoning, applying abstract reasoning, theories, and supporting that through real-world experiences, which today we call research. So Aristotle developed what we call the proto-scientific measurement method. That is a prototype to what we have today. So this involves observing, notation, classification, a lot of different types of observations, and he started with making note of the different types of animals, different types of plants, insects, astronomy, and all that sort of thing. So if we look at Aristotle's contributions in this area, he studied what other people wrote about the subject, looked for a general consensus about what they were writing, and then looked at a systematic way to relate it to different areas or different topics. So together we see, taken together, all of these constitute the basis or the foundation of science. What came from that is what we would call literature reviews, basically combining what everybody thought the knowledge was from the past. The Greeks were able to apply this to politics and botany, medicine, all kinds of areas. And then the Great Library at Alexandria was able to catalog and categorize academic material for all of different types of sciences. From there, we have the Great Age of Islamic contribution. They too further evolved the scientific and advanced the scientific method. There were some great contributors to this area, basically philosophers from Baghdad and Al-Andalus. They were building a body of knowledge, and they expanded it to today. We talk about the scientific method, and it started becoming more evolved there. Al-Haytham developed and expanded the scientific to something that we really recognize today. Number one, state an explicit problem or issue and look at the observations and do experiments. From there, number two, make a hypothesis as to what you think might happen when you start doing this experimentation. And three, collect some way of getting data. He didn't call it data, but it's basically data, and use it to come to a conclusion. Mathematics. And then, most importantly, number four, publish the findings. Some sort of library holding or some sort of way to write it down, okay? Ibn al-Haytham understood that this controlled, systematic experimentation and measurement was very important to get new knowledge, okay? And he used existing knowledge as the foundation to hone different questions that they had. He also believed that science was the path to ultimate truth, and that it would the only way to do that was to be skeptical and to continue questioning. He also formed the idea of what we now refer to as replication. So replication in research is really important. If you can't produce the same finding again, then it's useless, okay? You may take a medication once and it helped, but if it doesn't help you again the second time, we're in trouble, okay? So he also found that sometimes human beings, when they do research, they commit error or they have biases because, after all, we are only human. So we have to build into the research a way to control for these to make what we find important, okay? Other great contributions by Islamic scientists include Abu Jabir, also called Geber. He was referred to as the father of chemistry, and he advanced chemistry away from superstition and into modern research. Ibn Sina, also called Avicenna, who developed the idea of experimentation and the inductive method being the only way to get to the deductive method scientifically. Other Islamic scholars talked about consensus. When you have an idea that research is all about consensus, did everybody agree? Did everybody arrive at the same point through their experimenting? And an open review of science, not only for other people on a panel, but also for all of people, all of humanity. So these contributions to combined constitute what we call the Islamic Golden Age of science, okay? Now, the great Islamic houses of knowledge did experience a decline, and their work was picked up by the Renaissance scientists in Europe. So during the Renaissance, European scientists incorporated knowledge from the Muslims and the Greeks, and they added to it. They furthered it. The evolution continued. And they helped the scientific method. And some notables there were Roger Bacon, a very early European scientist. He looked at observation, hypothesis development, experimentation, and then documentation, is just like the Muslim scientists did. Francis Bacon, who supported Greek and Islamic importance of induction, observation, experimentation, and application of the research to other areas, other important areas. He also came up with the idea that further research could hone the conflicting research. So ideas that conflicted with each other, if you did more research, you might find that one was better suited for an explanation or prediction than another. Opposite of that was Descartes, known mostly for the saying, I think, therefore I am, or cogito ergo sum in Latin. He believed that the universe was like a machine, and if you could understand the basic laws of the universe, then you will be able to predict how everything acted. So he kind of was relegated to philosophy because he didn't really support the mathematical model of research, so that was Descartes. The one that's probably the most famous is Galileo, and he's remembered for gravity. But he also evolved science to the point where people like Albert Einstein and Stephen Hawking regard him as the father of modern science. Okay, so he shaped physics and other math-based fields, and his methods really propelled science away from religion. As you may or may not know, he was punished by the church for his theories, saying that they were offensive to God. And then later on, centuries later, he was pardoned by the church. So there you go. But he did take it away from religion, and he was very experimental. He used standardized methods. He did categorization and made a standard of measurement for all to be checked. The results could be checked. And he also encouraged repetition for other independent researchers, so that to see that the findings that they had could be replicated. So this period, the 16th and 17th centuries, are what we now know as the scientific revolution. So this further evolved the scientific method. The Royal Society of Science was established in 1660, and that created a panel of experts to advise, to guide, and to oversee information distribution. They also came up with a scientific journal. So another thing that they did that was important, they said that experimental, or what we today call empirical evidence, should precede a theory, okay? And so these things combined are the cornerstones of modern science. The Royal Society also created a panel to oversee the journals, and they had rigorous peer review or criticisms by other experts in the field, other scientists, which was initially thought of by the Muslim contributors. So the scientific revolution peaked with Sir Isaac Newton, who is widely credited with having the greatest contributions to the scientific method. That brings us to the 20th century, and where we left off, the previous era stood still for like 3 centuries. It only made small advances. But gradually, we saw more complexity, more application, an increase in the breadth and depth of science. And then we saw scholars starting to separate science into their specific disciplines, okay? And here we saw that the traditional methods of the absolute scientific method became really cumbersome for some other fields, okay? And this specifically applied to like human behavior, sociology, cognition, some social issues like political science, and things that involve man-made construct. A construct is a hypothetical example that we use that you can't actually pick up and hold, like this is knowledge. Here's a knowledge. Knowledge is a hypothetical construct. So that was very difficult to research, and we needed to come up with some different methods for those other types of areas, different than math or chemistry or physics. Okay, so the 20th century saw a big change in the scientific method to address these issues. On the next tape, we'll talk about Karl Popper and the people who followed him in the development of today's scientific method.